So deleting from a node can actually be very, very tricky. And right in front of me here, I have a linked list that contains 4 values. And we are going to work with several base cases right now. So there are some steps we should follow before deleting anything or any node from a list. And if you've read the notes that I've attached, you probably have already seen this or how I explain this there visually. Deleting requires 3 base cases. Now, the first base case is if we're deleting a node from the beginning. The second base case is if we're deleting a node that's in between 2 nodes. And the last base case is if we're deleting at the end of the list. Okay? So we have to write code to actually solve or maintain these 3 base cases. Now let's do the first base case. If we were deleting a node from the beginning of the list, it's really easy. So if right now we have a pointer called top, right? And top is pointing at 40. If we wanted to delete this, all we needed to do is move top to 50. So now we'll just say, oh, you know what, top? Point to the next list here. And then we would have this list cancelled. That would be so easy. And the second base case is actually the most difficult base case because that is where we introduce what we call the runner technique. And the runner technique is basically creating 2 pointers to run through the linked list. And you see what I'm talking about in a minute. So, this is named top. You can't play with this pointer because it's very, very important in the linked list process. So we have to create another pointer called core. And what core is basically going to do is core is going to point at top. And how we'll do that in code is say we just say core is equal to top. And then top can pass its address to core. And we are going to iterate to the list. Okay, so we're at the first node. Assuming we wanted to delete 50. So we're on the first node. This is not 50, so our core moves to 50. We are on the second node. Well, this is 50. We can't just delete 50 like this. We can't just say, set top to something here, or set core to something here, because if we delete 50 like this by removing just this pointer, we are going to tamper with this pointer because we're going to break the list. That's essentially what I'm saying. So you're going to destroy your whole linked list, and probably the only thing you'd have going for you is this way. So we would practically lose 40, the data 40. So the runner technique is saying that instead of using 1 pointer, we are going to use 2 pointers. So one is going to be called prev, and since the other one is core, and prev is going to be initially null. So it's pointing at nothing right now till we find the data 50. Now, we go to the first node and we say, this is 40, move to the second one, this is 50. And as core is moving, prev is also moving. So if core moves to the second node, prev moves to the first node. Okay, so a more visual, let me clean this up. So a more visual example would be to set this. So we had prev here before, here. And then we had core pointing to top. And note that this is still top. This is basically still top. Okay, so the top pointer does not move. It stays right where it is. We are just using core as the copy of a top pointer. Okay, so core stays in the first node and it says, is this 50? Well, this is not 50. So core moves to the second node. Now this is core, right? And now because core has moved, prev is also going to move. So prev is not pointing at the first node. Now core is going to say, is this 50? Well, yeah, this is 50. How do we delete 50 safely without disrupting every single thing in our linked list? Well, we have to follow a few steps. We could use the pointer because this is now prev, right? We'd set the pointer of prev to the next variable here. And how do we do this? Now this arrow here is signifying next. And this is also, every single arrow has a next, let's say next variable, right? So what we are saying is prev dot next. You get it? Because this is, the whole thing here is prev dot next. And prev dot next is pointing at this. It's this pointer, but the pointer is pointing at 50. But we don't want it to point at 50 anymore. We want it to point at 75. And 75 is the next pointer after core. So we'd say prev dot next is equal to core dot next. And we're saying core dot next because this is the whole core dot next, and core dot next is pointing at this. So now we are changing this pointer. At the end, we're going to have we cancel everything here. This link will be destroyed and this other link will be destroyed. My drawing looks a little bit messy here and I'm feeling a little bit uncomfortable, but I hope you are following along so this doesn't look strange. But yeah, that's basically all that we have to do if we're deleting from the middle, but it requires a lot of base cases. And the third base case is if we're deleting the last node, it's really easy. What we have to do is if core comes here, so if core was here, or rather, core was here. Now, if core is here, we know that prev is following core, and prev is going to be here. What we need to do is set prev.next to null. So now we would just say prev.next equal to null. And if you want to really understand what I'm doing here, at the end of this video, get a sheet of paper, draw it yourself, and try to think of how everything makes sense, because you're not going to understand it if you're just watching the video. You have to be able to visualize it on your own, and that's how you solve several linked list problems, by visualizing them. So now we are going to get into the coding aspect and try to implement this using code. Just put this one down, and we are going to create a delete method. And now we are going to use the parameter here is going to be an integer because we only have integer values, and if we wanted to delete something, it has to be an integer value. Remember when I said we would have two pointers, one the prev and the core, right? So the first thing you'd create is the prev, and prev is initially set to null. And the next thing we are going to do is the core pointer. Core is set to top because we are not going to play with top. Top is not to be messed with. Do not use top anyhow. And what we are going to do now is try to iterate over the list and search for what we want. We can do this using a while loop. And a reasonable condition is while core is not equal to null. That's the first condition, right? And core dot get data is not equal to what we are looking for. Move core. Core is equal to core dot get next. Now we've moved the pointer core, but we are not fulfilling the part where we said we also want to move the pointer prev. If we move core to the next node, then we've actually forfeited the original value or the initial value of core. So we have to do this after. So we say prev is equal to core just to preserve that value. And then say core is equal to core dot get next. So prev would no longer be null. And I don't know why that acted up like that. That's weird. And now we have our while loop. Now look at the condition here. We're saying if core is not equal to null, that means if our list is not empty. and core.getData is not equal to data, and the data inside of that node is not equal to the data we want to delete. Move prev to the initial position of core and move core to the next node. That's all we're saying here. Now we're going to do something else here. We're going to say if core is not equal to null. Now this is where the deletion is going to go into. And the reason why I said this is, remember how we used the while loop here, right? Saying, oh, if core is not equal to null and this, that, right? What if, and you know the and operator only evaluates when both conditions are true. If this condition is true and this condition is false, then we have found our data. Understand? So if core is not equal to null and core.getData is equal to data, we are not going to move. That means we found the node we want to delete. Now that core is not equal to null, we have to determine where exactly our pointers are. Okay? So now we said, oh, if core is not equal to null, what about prev? Let's say if prev is not equal to null. Well, if prev is not equal to null, then we are in the middle node. And what we want to do is set prev.next or .getNext rather. You know what? We are going to set next this time because we're actually moving pointers equal to core.getNext. And what we did here is try to delete the middle node. Well, if prev is equal to null and core is not equal to null, then the data we are trying to insert is at the beginning of the list. You get it? And to delete that, we can just use an else statement and say top is equal to core.getNext. Now we fulfill the three conditions that we need. We're expecting this method to actually work perfectly well. And I am going to do a little bit breakdown for what I did. So let's go back to the drawing board and cancel everything here. Show you what we did here. So if we go back to the code where we said if core is not equal to null and if prev is not equal to null, well, what condition could that be? Let's draw it here and try to understand it. Well, let's assume this is core and this is prev. In a situation where this core is pointing to an empty node, we said prev.setNext, that means set the next pointer of prev to core.getNext. And basically we are saying set this pointer to this. And now we're going to cancel this, and this is also going to drop. And prev is now going to, the next pointer of prev is going to point into a null value here. And it's the same thing if we had a node here. So we've actually killed two birds with one stone. And I'm not talking about literally killing birds. We've done two tasks in one code action or something. And that is all we need to know about the delete. Now let's test the delete function. But we can't test the delete function without actually writing a print node function. So let's write a legit print node function here. So now we've written a print statement to print all our nodes. And basically what I did here is I am not tampering with the top pointer. I'm setting a node variable called core, and core is going to take the place of top. And I'm saying while core is not equal to null, print the data in core and then move to the next node. So this continues to do this till we get to the end of the nodes. Okay, so I'm not 100% sure about this, but let's test it out to see if it works. So now that we've inserted, let's try to delete something. List.delete 90. Let's delete 90. So 90 is the first node, right? So let's say delete 90 and print node. Okay, perfect. Now we see that the print node does not print 90. That means our delete, what part doesn't, this part of our delete statement works. And I want to really print it out in a very ordered manner. So I'm just going to say print core.getData. Okay, so perfect. Should work perfectly now. So we know that the front deletion works. Let's say something in the middle. Let's say 43 and see if it works. Yes, perfect. So 43 is no longer in this list. And to actually prove that, I want to print the list before and after. And put this one here and then say so let's print this again to see that we actually really had that. Perfect. So now you can see we had 90 and we had 43 in the first print statement. And we no longer have 43 here. So the middle case works. Now let's print the last one. Let's try to delete the last element. So the last element should be 21 because it's the first to be inserted, sorry. So you see this one. So that should work too. Perfect. So 21 is no longer in the list. So now we actually did a delete nodes. We deleted nodes from the linked list and this method works now. We also did print values from a linked list and this also works. In the next video, we are going to be talking about how to search for items or nodes inside of a linked list.